Hello everyone, my name is Amir Mir. I'm a PhD student at TU Delft. I'm also a software developer in the FASTEN project. In this video, it's my pleasure to present the FASTEN demo. Let's load one Maven coordinate here on the bottom. Now I'm going to start our POM analyzer. It extracts dependency information for the Maven coordinate that I loaded now. Next, I'm gonna run our opacity generator. It generates a call graph again for the Maven coordinate that I loaded now, which we can see here now. It successfully generated a call graph for this Maven coordinate. On the top right, we have our Metadata Database plugin. Its job is basically to store call graphs and their metadata into the Postgres database. As we can see here, the metadata of the call graph is injected into the Postgres. Now, as we can see here, we have two packages in our packages table. For here, we have the callables tables, which represent nodes in the call graphs, and other tables here, such as edges, which represents the edges in the call graphs, and other Maven coordinates. Which you can see here, it was really quick and very fast. Now I would like to load our graph database plugin. Its job is basically to extract callables and edges from Postgres database and store them into our RocksDB database. Basically, we store the call graphs in the RocksDB database to have a faster in-memory access. And here we have our repo cloner, which basically clones source code files for the Maven coordinates if they are available. Now I would like to load the remaining Maven coordinates, which is now loaded into a Kafka topic. We can see that at the bottom, almost all the cores are fully loaded. And we can see that the plugins are working as expected, and we are generating call graphs and we are processing the call graphs back to the Postgres database. And the GraphDB is also storing edges and callables, basically the call graphs, into the RocksDB database. This query basically will show us the packages in terms of largest number of functions. Here we can see that the top 5 packages in terms of number of functions. For example, the top 1 package has around 17,000 functions in it. Perhaps this time we can also load one of our call graphs now, hopefully. Yes. We can see that here we have source and target. These strings basically, we call them FASTEN URI. We basically designed a specific format for representing nodes and edges in our call graphs. The source basically shows the source node in call graph, and the target basically shows the a target node in the call graph. Now I would like to perform another SQL query here, which shows us packages in terms of largest number of edges. Let's see. Yes, these are top 10 packages in terms of number of edges. We can see here the row number 1. We have around 142,000 edges for this specific middle coordinate that I highlighted here. The plugins are finished their jobs. Next, I would like to start our vulnerability analyzer plugin. Its job is to inject security vulnerabilities at the call graph level into our Postgres database. This SQL query shows us basically the vulnerable functions with a CV tag here. We have here we have a CVE field, and FASTEN URL basically it represents a function, a vulnerable function in this table. Now I would like to run another SQL query. This query that I pasted here, it basically tests whether this specific FASTEN URI, or I better say this function is vulnerable or not. Another SQL query, which is a procedure that basically shows us whether this package with this specific version is vulnerable or not. It takes a bit of time because it analyzes the vulnerabilities. As you can see here, it detects that this package is vulnerable with this specific version. It was basically the demo of the FASTEN project for the first half of the project. This is our website, fasten-project.eu. If you are interested in our project, please visit our website for more information. And I would like to ask you kindly to also follow us on Twitter if you're interested in this project. If you're a software developer and if you're interested to contribute to the project, we very welcome external collaborations. At the end, I would like to mention that this demo basically was the demonstration of the first half of the project. In the second half, we will have much more exciting news. Please follow us on Twitter if you are interested in the project. And again, thank you so much for watching this demo.